Hello and welcome to part 2 of module 19 in our C language series. Today we're going to focus our attention on building the parser that will evaluate expressions containing constants only. And going back to talking about expression parsing, but in the context of the recursive descent parser, every expression is a recursive data structure, meaning it can be defined in terms of itself. And so expressions will produce terms. The arrow there representing the word produce, the box brackets indicating optional elements. So we could have, for example, more than 2 terms in an expression. Terms in turn would produce factors. Factors would produce variable numbers or expressions. These, in fact, are what are known as the production rules of the expression. So now that we know the rules, let's look at the process itself. And we begin with determining the number of terms. We then determine what those terms consist of and the number of factors. Right? Once we know the number of factors in the expression, we get the first term. We recursively analyze the sub-expression if necessary. That would be if the first term, for example, is a parenthesized expression. And this will become clearer when we practice parsing in the next slide. We get each factor and perform the arithmetic operation, return from the recursive call, get the next term, and repeat steps 5 through 8 until there are no more terms, at which point we print the result. Now that we know the process, let's go parse. Right? So here we've got an expression. As per the process, we need to determine the number of terms. So here we have 2 terms. What do the terms consist of? Well, the first term consists of a number 14 and the second is a parenthesized expression consisting of a number and a variable. Determine the number of factors. So that's 3 factors, 14, 7 and C. Get the first term, that's 14, recursively analyze this sub-expression. Now this is not necessary because we do not really have an expression there, it's just a number. We get that factor. There's no arithmetic operation to perform, but we will store that multiplication sign. In a variable, for example, we return and get the next term. This is a parenthesized expression, so we go back to step 5. Recursively analyzing that sub-expression, we get each factor and perform the arithmetic operation. We return, get the next term, there's nothing there, so we print the result. Let's look at another. Again, determine the number of terms. We've got 2 terms there. What do the terms consist of? The first term consists of 2 numbers. The second term again is a parenthesized expression consisting of 2 numbers. Determine the number of factors. Here we've got 4. Get the first term. That's 9 divided by 3. We do not need to recursively analyze this, right? It's just a number divided by another number. So in effect, factor divided by factor, you can say. So we get each factor and perform the arithmetic operation. Return and get the next term. Now this is a parenthesized expression, so at step 5, we will recursively analyze this expression, get each factor and perform the arithmetic operation, return from the recursive call, get the next term, there's nothing there, and so we print the result. Look at the last one, determine the number of terms. Again, there's 2 terms. What do the terms consist of? Parenthesized expressions, both of them. Determine the number of factors. Again, we've got 4. Get the first term. Now we will recursively analyze this sub-expression, get each factor and perform that division. Return and get the next term. Then repeat steps 5 through 8. Right? So again, we recursively analyze the sub-expression, get each factor. That's 5 and 6. Perform the multiplication. Return to get the next term. There's no term, so we print the result. Now, having an idea of the parsing process, let's go ahead and write some code. So write code to develop a parser that evaluates constant expressions only. For that, we need to go to code blocks and we need to start a new project. So file, new project, click console application, click next, click C there, next, give your project a name. Click next and finish, right? And as in the last session, again, we've got main.c with some code in it. But now we need to create a new file. So click File and then New, File again, C, C++ source, click Next. Leave that as is, that's on C already. Click on the ellipsis there, put in the file name. So this will be evaluate expression. Save. Make sure these two are ticked, so click all and finish. And we're going to start with this file first. Hashtag include stdio.h and then hashtag include stdlib.h and hashtag include string.h, and we also need ctype.h. We have our directives hash define delimiter 1 and hash define variable 2 and hash define number 3. We need a global character pointer. We're going to use the extern storage specifier here, char star prog st. Right? We need char token of 80 bytes and we need char token type as well. Now the functions will be void evaluate expression. And that's going to take double star result. We'll define result in our main file later on. Then we have void evaluate expression 2. Again, that's going to take double star result. And then void evaluate expression 3. Again, taking double star result. And similarly, we have 4, 5, and 6. All of them taking star result as parameter. Now we have void store number. And that's going to take again double star result as parameter. And then we have void get token. No parameters there. And we have an error handler. So error handler. And that's going to take an integer error as parameter. And finally, we have our function is delimiter that is going to return an integer. I'm going to take character type C as parameter. So we start by writing the code for Eval Expr. This function is going to be the entry point for the parser. And of course, it will be called from our main function in main.c. We'll call get token here. And then we check if not start token, meaning if the expression is blank, then we call error handler, sending in the value 2. What 2 represents, we will see when we write the code for error handler and we return. Otherwise, we call eval expr 2. Okay, sending in result. Okay, so that's the argument. And that ends the code for eval expr. Now let's write the code for eval expr2. And again, that's bringing in the parameter double star result. Within this function, we have character type op for operator and double temp. Okay, we call eval expr3, sending in result as argument, and then we check while op equal to, so we are assigning to op token, star token, and we're checking if the token is a plus sign, meaning an addition operator, or op equal to a minus sign. Okay, if that's true, then we call get token again. Why? Because if we have an operator, then we need another operand. We call eval expr3. What eval expr3 will do, we'll see. Right? So we call eval expr3, but we send in the address of temp. Okay. And we then use a switch on op, checking. If it is a plus, then we need to do addition. If it's a minus, then subtraction. So case minus, then star result equal to star result minus temp. Okay, and break case plus or addition, then star result equal to star result plus temp, and break. Right? And that completes the code for eval expr2. We just return after this. Now we write the code for the next function, eval expr3. And this has again got the parameter double star result. Okay. Now here, remember we can also use a register for char. So register char op, we can have double temp there, and then eval expr4 is going to be called, passing in result. Then we check while, again we are assigning to op star token, and eval expr3 is checking for whether token contains a multiplication sign, so equal to star, or op equal to the division sign, or op is equal to the percentage sign, which is the modulo sign. If that is true, then we call get token again, right? Because we've got to get that operand, and then we call eval expr4, right? Sending in the address of temp. Then we use the switch again on op, and we check case star, then we say a star result equal to star result multiplied by temp. Break. Check for the division sign, then star result equal to star result divided by 10. Break. And case a percentage sign, which means it's a modulo, then star result equal to star result. Now, when we say percentage, we will need to use a cast int integer, that is casting temp to integer type. Okay, and of course break. Right, so this completes the code for Eval Expr 3. After this, just return. Next, Eval Expr 4, which is going to check for exponentiation. And again, parameters double star result. So within this function, we have double temp x register int t, and we are calling eval expr 5, sending in result as the argument. And here we check if star token is equal to the exponentiation sign, then again we've got to get token, right, to get the operand, and then call eval expr5, which by the way is checking for a unary plus or minus. So we send in the address of temp, and then ex equal to star result. And we check if temp is equal to a 0.0, then of course result will be 1. Right, so result equal to 1.0. Remember, result is double or of type double, therefore 1.0 or 0.0, and return. Otherwise, we have a for loop for t equal to temp minus 1. Okay, and then t less than 0 minus t. And within this for, this one statement, star result equal to star result multiplied by, and we need to use a cast to the double type, so star double, double of x, x. Right, so this will calculate the exponent, you can say, right, and then of course we need to return. Right, so this completes the code for Eval Expr 4. Now we write the code for the next function. So void eval expr 5, and this one is checking for the unary plus or minus. So double star result is the parameter, and here we have char op equal to 0, and then we can say if token type is equal to delimiter. Okay, and star token equal to a plus, unary plus, or star token equal to a unary minus. Then we say OP equal to star token, and we get token because remember, if we have a unary minus, for example, it should be minus and then 5 or 6 or 10 or whatever. So we're getting the number here when we're calling get token, right? After that, we call eval expr 6, which is checking for parenthesis. So take result as argument. Now we check if op is equal to a minus sign, then we say star result equal to minus star result, right? And then of course we need to return. So that completes the code for eval expr 5. Now we write the code for eval expr 6. Bringing in double star result as parameter, and this one is checking for brackets or parentheses. So if star token is equal to an opening bracket, so if we have an opening bracket, then we need to call get token because there should be a number there. Then we will call eval expr 2. Right, we'll come back here and we need to have a closing bracket. So we check that now. So if star token not equal to a closing bracket, then we have mismatched brackets, right? So we call handle error. And we send in the number 1 and then get token again, right? Else, if it's not a bracket, then we can just store the number. So store num, and we send in the number to be stored, that is in result. Okay, and we need to return from this function. So here we put in our return statement, right? Now this particular function handle error, I hope we spelled it the same way. Let me just check. Oh, we've called it error handler. No wonder I didn't get that prompt. So this should be error handler, and there we are, right? Sending in 1. I think the other we have uses correct spelling. Yeah, okay, that's fine. So moving on now. Now we write the code for store num. So void store num, and that's bringing in again double star result. Within this function, we check if token type is equal to number, right? Then we say star result equal to ASCII to float, A to F of token, and we'll put a printf statement here just to show us the value. So printf Okay, just for our reference, that is. And then we need to call get token again. See if we get an operator, for example, and return. Okay. If token type is not a number, then we'll call error handler and send in the value 0. Okay, what 0 is or what 0 represents, we'll see when we write the code for error handler, which is the next function actually. So now we have void error handler, and that's bringing in integer type error. So here we have an array. It's a two-dimensional array that will be of static char type star air equal to, and it will consist of messages. So syntax errors 1, that's error 0, right? And then we have another unbalanced parenthesis, right? And we'll have one more, which is no expression present, you can say. That completes that array. And all we'll do here in this function is printf %s\n, comma, air of error. Right, so according to the number, it will print the error or the error message. Now let's write get token. So void get token. And here there's no parameters. So here we have char star temp and token type equal to 0, temp equal to token, right? And star temp equal to \0. This code may look familiar to you because it's the same as we did in the last session. So if not star prog st, then return, right? If there's no token. Otherwise, we need to remove the spaces. So while is space star prog st, and all we do here is we say ++ prog st. We're moving the pointer forward. Once we have passed all the spaces, we need to check first if the token is a delimiter. So str, chr, and we have all the operators. So plus, minus, multiply, divide, percentage exponentiation equal to, and the parenthesis, comma, prog st, right? Or rather, star prog st. Then this is a delimiter. So printf delimiter, this is again for our reference, %c \n, comma, star prog st, right? And token type equal to delimiter. And then move on to the next element or token. So temp ++ equal to star prog st ++. Right? Else, if is alpha, star prog st. Then remember we've got to call is delimiter. So while not is delimiter, that's here. And of course that's taking in star prog st as argument. Then star temp plus plus equal to star prog st plus plus. Right? And then of course token type equal to variable. Okay. Then we've got to check if it's a number. So else if is digit. Right? Star prog st. And then again we've got to call is delimiter. So while not is delimiter, and of course there's going to be star prog st going in as argument. Then star temp plus plus equal to star prog st plus plus. Right? Here I'm going to put in a printf statement. Right? We're not putting in one here because this version of the parser is not dealing with variables. So printf number and then %s /n comma token. Right? And then token type equal to number. And of course star temp equal to \0 to end that string. So that completes the code for get token. Now we will write the code for is delimiter. So int is delimiter, and that's going to bring in char type C. Within this function we use strchr. So if strchr, and we put in all the operators. So plus, minus, multiply, divide, percentage, exponentiation equal to, and parenthesis. Right? Checking for that in C. Or if you recall in the last session we checked for tab characters, or C equal to \r, which is a carriage return, or C equal to a null. Then return 1, otherwise return 0. So that completes the code for this file. Now we write the code in main.c. So first of all, we've got to include string.h. So hash include string.h. Right? And we need the global character pointer. So char star prog st. Right? We also need the function void eval expr, which we're going to call from here, and of course that's taking in double star result. Right? Now in the main function just delete the 2 lines and put in double result and char star ptr. Instead of using an array, we're going to use malloc to allot space for the expression. So ptr equal to malloc. Let's ask for 100 bytes there or 100 spaces. If not ptr, as in if malloc returned a null, then you know what to do. Printf out of memory and exit 1, right? Otherwise, we have a do while loop. So do, we have prog st initialized to ptr, and then printf enter expression. I'm going to use get s here. So get s prog st, that is, right? And if not star prog st, then break out of this loop, that is the do while loop. Otherwise, we call eval expr. Remember, that's the starting point or the entry point for the parser, sending in ampersand result. And then we need to print the result. So printf result is %.2f /n, comma, result. Right, and this loop will continue as long as we do not have a null while star ptr. So that completes the code for the main file, right? Now we can build this, see if there are any errors. So here we have 78 invalid operands to binary. We have double and we have int. So we have this one casted to int type. So this one has to be cast as well. So just put in there int star result, right? Otherwise it's conflicting. Okay, let's try that again. Oh, this should be star result. Okay, so let's try that again. Okay, so that's a spelling error or a typo. Okay, so now we don't have any errors. Let's run it. Activate that window and put in an expression. So let's put in 10 minus 2 multiplied by 4. So now you can see we have that number 10. Result is 10.00 because that's ASCII to float, of course. Then we get the next number 2. Result is 2. We get that multiplication sign. Note that we get that negative sign as well, right? We get the number 4. So we have all our tokens, right? And then we have result is 4 as well. We're storing ASCII to float of all these numbers. And finally, the result of the entire expression is 2. Now, if you want to see what exactly is happening here, what I suggest you do is in expr3, that's evaluate expr3, right? When we're checking for that multiplication sign, just before that switch statement, you can put in a printf. So printf, right? And then we can say temp, comma, star result. And just outside the while, that's here, we can put another printf saying, comma, result. Okay. So what we'll get to see here is what temp and result is, and then what result is after the calculation is done. Similarly, we can take the same line and copy it into expression 2. again just above that switch. So here, and this printf, we can put it again here outside the while. Okay, so now if we just build and run, okay, there's a problem here. What does it say? Oh, it has to be star result. That's the problem there. And here, again, we would have to say star result. That's here. Try that again. Build. Okay, so that's 0 errors. Run. Now enter the same expression. So 10 minus 2 multiplied by 4. You can see we have 10. The number in store, we're storing the ASCII to float of the number. We get the delimiter. That's a negative sign. After arithmetic operation, result is 10, right? Then we get 2. Result is 2, as in we are storing the ASCII to float value of 2. Then we're getting the multiplication sign. Number next that we get is 4, storing the ASCII of 4. Now we come back to, this is Eval Expr 3. Temp is 4, result is 2. After arithmetic operation, we do a 4 multiplied by 2, so we get 8. Then we go out of Expr 3, that is, to Expr 2. Eval Expr 2. My temp is 8 and result is 10. So 10 minus 8 gives us 2. Right, so you can play around with this program just to understand better how that code works. But what I have for you is a visual so that you can understand what's happening in the code. So that was our input. We have our main function. We are calling Eval Expr, which is the entry point to the parser. We then get token 10. We call Eval Expr 2, which calls Eval Expr 3, which calls 4, 5, 6. And we call store num, where we store the ASCII to float value of 10. Then we call get token. We get the negative sign or the subtraction operator. And we go back, returning from all functions until we reach Expr 2, where we're checking for that minus sign. So we store that in the variable OP, and then we call get token again. So we get the next token, which is 2, right? And then we call Eval Expr 3, which calls 4, 5, 6, and we store the ASCII to float of 2, and we call get token again, where we get the multiplication sign. Now we return from these functions until we reach Eval Expr 3, where we are storing that multiplication operator, right? And then we are calling get token again. We get 4, right? And we call Eval Expr 4, which calls 5 and 6, and we store the ASCII to float of 4. And we call get token, no more tokens there. So we return back to this point. And remember, we would then do that operation, and so we would get 8, right? Then we return to Eval Expr 2. Again, we do that operation. That's 10 minus 8. And so we get 2. We return to Eval Expr, which returns in turn to main, where we print the result. So I hope that's clear. This ends our session for today. In the next session, we'll introduce variables so that the parser can handle variables as well as part of the expression. So till then, take care, stay safe. Bye.